Welcome back to the Rochester Institute of Technology, where today we will be going over sample preparation, sample loading, and a software tutorial for the TA Discovery Differential Scanning Calorimeter. First, the materials that you'll need for sample preparation are listed below. You'll need an analytical balance, your sample, a weigh boat, your lids and pans, a spatula and tweezers, as well as the pan press. All of these will be in the lab A155. First, we are going to start by tearing our weigh boat. For our DSC, we use the pans and lids that are designated by the blue label in the top right corner. After your weigh boat has been tared, we are going to mass the pan and the lid. Now, when you're taking the initial mass, you do not have to have the lid on top of the pan. However, it is a preference of mine. So here I am placing the lid onto the pan before putting it back into the balance. You are going to record the mass of the pan plus the lid. From here, we are going to add our sample to the pan. You want your sample to be between 10 and 20 milligrams. Today, we are using indium as it is a standard for the DSC. Now, you'll see that I'm going to replace the lid. Again, this is entirely preferential. And then place it back into the balance. Ultimately, you're going to record this mass, and you are going to subtract this mass from the previous mass that you recorded in order to find the mass of your sample. Now, we are going to press the pan shut. You'll take the stand, which is this small blue circle, and you're going to place your sample and the pan into the circle. You'll want to make sure that your lid is on correctly and everything, so it should look kind of like this. And then we are going to put it into the press. And from here, your sample should be sealed and be ready to be put into the DSC. It is very important that you analyze your sample and make sure that the top is not warped. It should look like this. Now that we have reviewed how to prepare a sample, we will go over the different parts of the instrument. First, you'll see the gas regulators at the top. Then we have our refrigerated cooling system, and finally we have the differential scanning calorimeter itself. Just to go into a little bit more depth about the hardware of the instrument, these are the regulators. You'll notice that we have the nitrogen valve, which is going to be gas 1, and we have the air valve, which is going to be gas 2. Both of these valves can be found behind the monitor. From here, we are going to go over some more hardware. You can see on the DSC we have a manual control panel as well as a sample dock. It's important to note that we have slot 4 used as a control for the system, so please do not move this. Next, onto the refrigerated cooling system. First, we have our refrigerated cooling system, but if you look closer on the panel, you can see that there's a power switch and an indicator light. Before you begin your run, you should give this about 15 minutes to warm up. So turn on the power and then probably prepare your sample. Furthermore, you can also see that there is the manual event switch. Normally it will be switched into manual, however, when you begin your run, you should switch this into the event mode. In order to load your sample into the instrument, simply place your pan into one of the numbered spaces. Now to address the DSC software, you will log into the computer using your RIT login and password. Then, you will select the TA Trio software on the desktop. From there, you'll have to make sure that you're selecting the DSC and you'll press Connect. In order to make a method, first you will go to Create a New Run in the running queue. From here, you'll see that there's the opportunity to give your sample a name, fill out any of the masses that you previously found, as well as noting that you are the operator. As you scroll down, you will see the segments box. When you go down to the segments box, you will see several different options that you can choose from in order to customize your method for your sample. If you would like, you can come back to this slide for a reference. However, we are simply going to go over some of the most used ones today. In the majority of the methods that we use for the DSC, we are going to have equilibrate, which essentially brings the sample to a designated equilibrium temperature. You generally have this at the beginning of your method. Furthermore, generally there is a ramp option, which allows you to increase or decrease the temperature at a certain rate to a designated temperature. Next, we also have an isotherm option, which allows you to keep the sample at a constant temperature for a designated amount of time. And finally, something that is always essential that you'll have to do at the beginning of your method is selecting the gas and the mass flow. Recall from a previous slide that nitrogen is gas 1 and air is gas 2. Furthermore, the mass flow will allow you to choose the rate at which the gas is going through the system, which we generally have it set to 40 milliliters per minute. Ultimately, this is a good example of a basic method that you can use, and one thing that you'll have to remember to do is click apply in order to save this as your method. If you do not click apply, then none of your selected methods will actually run if you just simply tell the sample to start running. And finally, at the bottom, you can see some of our advanced options, and we generally have the load windows, use standby temperature clicked or checked, as well as at the end of the test, we have the use standby temperature as well. Now that we have completely prepared our method, we will begin our run. First, you can see that our run is queued up. We have all of our masses recorded, we have our sequence, and we have all the rest of our method prepared. So from here we can click Start. It may take a few minutes for your sample to get all prepared. However, in a few moments, the graph will appear. Once the graph appears, you can look to the right and you can actually see where you are in the method list, and you should be able to see your reaction and your sample acquiring data in real time. So, this is after we have collected our data. You'll notice that our run and our method is still displayed here. However, we are now in the results section rather than the experiments section. So now we can go into the Overlay tab and we'll actually see our data. There's a couple different ways that we can analyze this. You'll have this drop-down menu and it'll have several different things that you can look for. However, I'm simply going to show you how to integrate a peak for enthalpy. All you have to do is double click your graph and then drag and decide where you would like to end. And then from there, you'll just click Analyze, and it will give us our results. From here, I'm going to show you another way we can actually do this. So we're going to say delete all. And you can also do this by simply double clicking and dragging again. And you can right click. And from here, you can go to Analyze and you can select what you would like to analyze about your graph. And ultimately, you should say accept and yield the same result. And this is accurate for indium because it should be 156. Thank you for watching. If you have any further questions or would like to schedule an in-person training, contact the RIT School of Chemistry and Material Science Instrumentation Lab Manager.